Good morning, everyone, and welcome to another video. Today, we're going to be discussing exponents with an emphasis on evaluating powers. So let's go ahead and get started. So we're going to begin today's discussion by introducing grouping symbols, but I'm pretty sure that you are familiar with this concept already from everyday life. Before Instagram, before Facebook, we used to text on the phone, if you can believe that or not. And we have parentheses. I'm pretty sure everyone is familiar with parentheses and brackets, but in math, they have a really special meaning and they're called grouping symbols. And their job is to help us keep our work organized. They give us direction and they tell us which order to perform operations. So grouping symbols are really important. We already introduced them before in the previous video when we talked about the different ways that we can write multiplication. So these are going to come in handy. And they make a huge difference in the manner in which we approach a problem as well as our overall result. And are you a math skeptic? Do you not believe that grouping symbols are important? Maybe you're just a little bit suspicious of them. So let's go ahead and try an example. Here we have to the left a variable expression 2x raised to the fourth power, and to the right we have the same, almost the same variable expression. This time we're using grouping symbols around the 2x, and this quantity, this product of 2 and x, is raised to the fourth. And we're asked to evaluate the variable expression when x is equal to 2, and we're going to do just that. So we're going to substitute. We said x is equal to 2, so wherever I see an x, I'm going to put 2. Now remember what we learned about exponents. We are going to evaluate this. So I'm going to write out my factors of 2. And now I'm going to multiply. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And 2 times 16 is 32. Okay, simple enough. Now let's go on to the one on the right. So again, we're going to substitute x equal to 2. So we have, actually, I'm going to use a big bracket for this. So I'm going to write 2 times 2 and the bracket with the 4 on the outside. Okay, so now I'm going to do the multiplication on the inside. That'll be 4, and 4 will be raised to the fourth power. And I'm going to write 4 times 4 times 4 times 4, and all of this will be 256. Yeah. So take a look at this difference. To the right, our result was 32. To the left, I apologize. To the left, our result was 32, and to the right, our result was 256. So grouping symbols make a world of a difference. And as an example to how they guide us, here at the very top on the left, we had 2 times this 2 raised to the fourth, and we did this inside first. Then we took care of this multiplication, and then we can multiply with the 2 and the 16. Same on the right side, we had this quantity in here inside the bracket, so we multiplied this first, then we carried out our exponent, and then we were able to do this multiplication. So there are many different ways as you advance in algebra that you can take care of exponents, but for now this is our technique that we're going to use. So hopefully that made you believe in the power of grouping symbols. And we're going to move to the next problem, which is actually a concept check. So if you haven't seen the previous video, Exponents Part 1, now would be a really good time to see it because we're going to review some vocabulary. So let's actually read the first question. It says, in the expression 2 raised to the third power, or 2 cubed, the 2 is the... What is the 2? Do you remember the vocabulary that we talked about? 2 would be the base. Remember? We talked about like 4 raised to the n. 4 would be our base. and n would be, and that's actually the next question. So this would be our base. In the expression 4 to the 5th power, the 5 is the, but it's 5. If 2 up here is the base, then 5 up here is the exponent. Okay, so you would write exponent up here. Going on to the third one, the expression 9 squared is called a. So if 9 is the base, 2 is the exponent, what is this entire expression called? It's called a power. Okay. And finally, for the last one, the two kinds of grouping symbols are, and we just learned this, what are the two kinds of grouping symbols? They are parentheses and brackets. And they help us stay organized. They give us direction and how to approach a problem, and they make a big difference in terms of our results and our overall direction. So hopefully that was a good review of the vocabulary of important definitions. It's always important to reiterate those so that we understand what we're actually doing and not just mindlessly doing work, okay? So hopefully that was helpful. Now let's move on to the next slide. So today's discussion, we're going to talk about volume. We already discussed area, and volume, I believe, is a natural progression, especially since now we will be discussing exponents. So volume is defined as the amount of space an object occupies in 3 dimensions. And down here, I have provided you with 3 figures, two of which we've already discussed, the triangle and the rectangle, and a new one, which is this cube. So we can use exponents to express the units of volume as well as area, as I'm sure you have noticed. So let's go ahead and review. So for this triangle, starting on the far left, we have this right triangle. And remember, we had a base and a height. So for the area, our area of a triangle was 1/2 base times height. Now for this rectangle going on to the middle figure, we said that a rectangle had a length and it had a width. So the area of this rectangle, the amount of space that it takes up in 2 dimensions, will be length times width. And now onto our new concept, we have our cube. So we're going to have this side, this length of this side, and this side of over here. So this times this would give us area, but we want volume, so we would go up. So we want 3 dimensions. So we would multiply all these 3 side lengths together. So it would be side cubed. Okay. So a word about units. So here we would have units, whatever we have, we would have units squared. So if we have inches, it would be inches squared. And here too, it would be units, whatever you have, centimeters, meters, it would be squared. But for volume, we would have units, any guesses? Cubed. Units cubed or units raised to the 3rd power. Okay, so let's go ahead and jot all this down so that we can move on to the next slide. So let's try an example. You want to buy a fish tank for your friend. The fish tank has the shape of a cube. Each inner edge S is 3 feet long, and we're asked to find the volume in cubic feet. So before we begin, remember we said cubic means 3. It's 3, so it would be like units cubed. So here it would be feet cubed. Okay? So our approach down here, how we're going to tackle the problem is we're going to write the formula for the volume of a cube we just learned. We're going to substitute our side length into this formula, and then we're going to evaluate the power. Okay? So let's go ahead and go to the next slide where we have a little bit more room. So we're going to, first step is we're going to write our formula for volume. So it'll be volume is equal to S cubed. And this is for the volume of a cube. And then to the right, you see we have our cubed. We already labeled our lengths, our sides. So this side, then this side right here, and then this height up here. Okay, so let's go ahead and we're going to substitute. So we said we're told that S is equal to 3 feet. So we're going to substitute 3 feet for S for this equation. So V is equal to 3 feet cubed. Now we're going to evaluate this power. So I'm going to write 3 factors of 3, and I'm going to write feet cubed. Okay, so now I carry out my multiplication. So this will be 3 times 3 is 9. 9 times 3 will be 27 feet cubed. And this is the volume or the amount of space that this cube or this fish tank will take up in 3 dimensions. Okay, so hopefully that made sense. If you have any questions, I'll be sure to get to them. But for now, we're going to move on to the next slide. Our next example is about a fireproof safe, and we are told that it is designed in the shape of a cube and the length of the edge of the cube is 4 meters. What is the volume of the fireplace? So our approach is going to be the same. We're going to write the formula for the volume of a cube. We're going to substitute our given value and then evaluate. Okay, so for the first step, our volume for the cube will be V is equal to S cubed. And we're told in the problem that the side lengths of this fireproof safe is 4 meters. Okay, so that's 4 meters here, 4 meters here, and 4 meters up. Okay, now we're going to substitute. So V is going to equal 4 meters cubed. Now we can evaluate this. So I'm going to write volume is equal to 4 times 4 times 4 times meters cubed. And this will actually give me 64 meters cubed. So this is a volume that this fireproof safe will take up in 3 dimensions. Okay, our length, our width, and our height. Okay, so we're going to move on. And that is the conclusion of this practice set. Next time we will work on another practice set that will encompass both of the lectures that we had. So it will include evaluating powers, it will be evaluating variable expressions, writing statements into exponential form, and it will also include volume. So I hope that you can join me for that. Thank you so much for your time and attention today. And that's it for today, and I hope you enjoy the rest of your day.